So let's start the session. So in last session we have seen the units and dimensions, right? So last question of the session is the centripetal force F acting on a particle moving uniformly in a circle may depends upon. So what is the given term here? So F is the force, depends upon mass, velocity and radius. So F is directly proportional to mass, velocity, radius. So mass power A, velocity power B, radius power C. So what is the dimension of force? Dimensional formula? ml T power minus 2 is the dimension formula for the force. So before that, let me equate that. So F is equals to K m power A, V power B, R power C. To remove the proportionality, I have added a constant called K. So the dimension formula is ml T power minus 2 is equals to K into what is the mass? M power A, velocity L T power minus 1 power B, right? No, velocity, radius is L power C. So take the powers inside the brackets. So K m power A, L power B, T power minus B, L power C. So here L and L, if bases are same, add it. So m power A, L power B plus C, T power minus B. Here ml power T, ml power, mlt power minus 2, na? That's it. So what else? Now m, equate the powers. A is equals to 1, right now. Then B plus C is equals to 1, and then T, that is
B equals to 2.
This is minus B, no? Yes.
Minus B equals to minus 2.
Minus B equals to minus 2. So B equals to 2, A equals to 1. What about C?
2 plus C equals to 1.
2 plus C equals to 1, where C equals to minus 1. So C will be equals to minus 1. Now take out the equation which we have written. So F is directly proportional to m power 1, then V power 2, then C power and R power minus 1.
MV by R. MV
So F is directly proportional to mv square by R. This is the formula. We need to get it. Okay, this is the thing. Is there any doubt in this? We can go for the measurements and errors now. So the next topic is measurements and errors. So what is the meaning of measurement first?
to measure something.
To measure the any length or anything, any quantity, okay, any physical quantity. Now what is the meaning of errors?
Error in measuring the physical.
So if 5 persons are there or 10 persons are there, if I give a scale for every person, like same scale, okay, if I ask them to measure the given object, will they able to measure the same number? No, right? Some may get 10, some may get 10.1 and some may get 9.9 also, or some may get 9.95, right? Na? So they are lying, whatever it is. Okay, some errors has been made, right? No, some errors has been made. So if I ask to write you alphabets, you will write neatly, right? Na? If I ask the first standard student to write the alphabets, he will write like this. Greek letters are okay, right now. So now the thing is errors in measurement and least count. First topic we are going to see. So errors in measurement we have seen now, like the errors has been happened. But what about the least count? I have given the scale, right now I have given the scale. So normal scale we are using in the daily life, no, for the line which we draw. So in that, what is the least count of that?
0.1 cm.
0.1 centimeter, right? Now, so if I want to measure a bottle or any like any physical quantity, any object, okay, will I able to measure 0.99 or 10.99?
10.99.
10.99 centimeter.
No.
10.9 is possible, right? Na? 10.9 centimeter is possible, like 0.1 only, no? 0.1, 0.2, 0.3 up to 0.9, next is 1 centimeter. 10.9 is possible, but 10.99 centimeter is not possible in that scale. But I should use some other scale to measure. Some other scale to measure, right now. So whatever the quantity which we are using for measuring, those quantity will have the least number. That least number is called as least count. Okay, least count. Understood? So errors in measurement we have seen, and the least number which we are using is least count. Okay. Now examples we will take. The first example is, if we measure a length, L is equals to 6.24 centimeter. Okay, this is the length we measured with the help of a vernier caliper, like it's an object to measure. Okay, then what is the least count? Now we have seen about least count, then what is the least count in this? 0.01 centimeter, right? So 0.01 centimeter. Good. So how many significant figures? Now significant figures are the counting numbers, like I need to count. Okay, 10.99 I said, or 10.9 I said. How many numbers are there? 4. Then 3. 10.99 is 4. 10.9 is 3. So how many significants are in this? 3 significant figures. Okay. Now the thing is, which digits are absolutely correct and which are absolutely doubtful in this? 6.24 centimeter we got. If I ask some other 3 person, like some 3 other person no, has to count, he will give 6.23, 6.25. So in this, which is correct numbers? 6 and 2 are correct. So 4 is doubtful, na? Yes or no? So the correct numbers are 6 and 2. The doubtful numbers are 4. So similarly, one more question I have taken, that is L is equals to 3.267 centimeter. So similarly, what is the least count for this? 0.001. So maximum uncertainty. So one more word is maximum uncertainty, which is also least count. Okay, 0.001. So how many significants now? 4 significants, right? So what are the absolute correct and which are the doubtful numbers? 3, 6, 3, 2 and 6 are correct number, absolutely correct, and 7 is the doubtful number, right now. So any doubt in this slide? Clear? So least count we got clear. Significant numbers is like the number which is used to count it, counting numbers. Okay. In upcoming slides we will see what are the significant figures and how to count and how to round it off. Okay. Now the significant figure, they represent the digits in numbers that contribute to its accuracy. Significant figures indicates how preciously a measurement is made. Then the more significant figure number has, then more accurate the measurement is considered to be. Suppose if I take the object, if I measure 10 centimeter I got, okay, some other scale I used, centimeter scale I used, then millimeter scale I used, some other scale I am using, kilometer scale, meter scale, centimeter scale, okay, whatever it is. So 10 centimeter, if I again use some other scale, this is having least count is 1 centimeter, okay. Second scale I am using, the least count is 0.1 centimeter, so I am getting this as 10.1. Third scale I am having 0.01 centimeter, so I am getting 10.12 centimeter. For example, I am taking, okay, 10 centimeter, 10.1 centimeter, 10.12 centimeter I got. So again I am taking some other least count 0.001. Now I am measuring the same object, everything is same object. Okay, so now I am getting as 10.128. 1 to 8. So when I see this one 10 I am getting, this one 10.1 I am getting, this one is 10.12 I am getting, and this one is 10.128 I am getting. So when I take the least count, more significant I am getting.
More accurate.
So when the numbers are increased, significant numbers are increased, more accuracy.
More accurate.
Right now? So more significant,
More accurate.
more accuracy. Okay, this is the important point you need to keep in mind. When significant numbers are increased, it is having more accuracy. Okay. Now the rules for counting the significant figures. Rule number 1, all non-zero digits are significant. All non-zero digits are significant. We will go by rule one by one. Okay, don't confuse between the rules. Okay, so first one, if I see, if I consider 0, it is non-significant. Other than 0, everything are significant. When we go for rule number 2, zeros appearing between two non-zero digits. Okay, first rule they said zeros are non-significant, but when I take the zeros in between the non-zero numbers, those are considered as a significant. When I take the 1000, it is having only one significant value, right? No, when I take 1001, it is having 4 significant values. Rule number 3, trailing zeros after decimal places are significant. What they told? Trailing zeros in the sense after decimal, like after some numbers, like the last zeros are appearing, no, those are significant, like decimal, only for decimal. If I take 1000, okay, 1000, how many significant? 1. If I take 1.000, how many significant? 4. Simple case, in the previous examples I have told 0.001 centimeter as the least count. Na? Suppose I measured this object and I got the value as 10.00. Is that this also correct and this also correct? No, both are correct. 10, 10, but according to the least count I have taken 0.00. Right? No? Yes or no?
How many significant figures? 3 or 4?
Here 4.
How 4? But decimal point ka only 0 the.
That's what I told. Up to rule number 3, no. Up to rule number 3, if you see, how many significant?
1.
4. That's what I told. Don't confuse between the every rules. We'll go by rule one by one. Okay. First rule, zeros are considered as a not significant. But when we come for the second rule, in between non-zero numbers are significant. But when we go for the third rule, zeros, like which is at the end, are considered as a significant after decimal, that too. Okay.
3, right?
How? 1, 2, 3, 4.
That 0 is insignificant.
How?
Second 0. Because
Then how you will take?
It is in between. It is not in between two non-zero digits or not. It is ending with 0.
I'll come to your point. So rule number 4 is, yeah, before that we'll see one more thing. So measurement, accuracy. So 6.4, you come to this point, you will understand now. Okay. So 6.4 centimeter. What is the least count? 0.1 centimeter. 6.40, 0.01 centimeter. 6.400 centimeter. 0.001 centimeter. So if the numbers lies between 6.3, 6.5, here 6.39 and 6.41, 6.399 and 6.401. So if I see the significance, how many significance are there? 2, 3, 4. So when I see that significance are increasing, accuracy increasing. Now come to that point now. Here you asked no. Yeah, in this case you asked no. So here 10 centimeter was there. So how many significance?
1.
Don't see the rules. Initially we have seen 2 significance. Numbers, counting numbers are significant before seeing the rules. So here 3 significant, here 4 significance, right? Suppose the object is 10.01, how many significant? 4, no? So here accuracy is increasing, like what I told, when least counts are increasing, accuracy increases, right now. So once we complete the every rule, then we go for the question what you asked, okay. Rule number 4, the power of 10 are not counted as a significant figure. So power of 10 in the sense exponents, okay. Power of 10, it can be positive, it can be negative, okay. It should not be considered as a significant. Rule number 5, if a measurement is less than 1, then all zeros occurring to the left of the last non-zero digits are not significant. What I told, if number is less than 1, number is less than 1 means 0 point something, right? No, suppose the number having zeros before the non-zero numbers, okay, those are considered as a non-significant. This one I can write like this, no, 0.00 is there, no? How can I write 0.00 in terms of power?
42 into 10 to the power minus 4.
Yes, 42 into 10 to the power minus 4. 42 into 10 power minus 4. So how many significant? 2 significant. Power is not significant. So how many significant? 2 significant. Right now? Rule number 6. Change in units of measurement of a quantity does not change the number of significant figures. Suppose 1 kilometer is there. If I convert 1 kilometer to meter, how many meters? 1000 meters. 1 kilometer having how many significant figure? 1. So 1000 meters? 1. 1 kilometer equals to 1000 meter. So how many significant? 1 significant. Here also 1. This 0 I should not count, na? Yes or no? Which is nothing but 1 into 10 power 3. Exponents are not counted. Only 1 significance are there. Right now? 7.2 centimeter, 2 significant. 0.072 meter, 2 significance. 0.00072 kilometer, 2 significance. 7.2 into 10 power 7 nanometer, 2 significance. So if any values is there, if I change the unit, significant figures doesn't change. Okay. Rule number 7, the terminal or trailing 0 in a number without a decimal point are not significant. This sometimes arises due to change of units. Okay. So example 264 meter is nothing but 26400 centimeter. So here zeros are there. 1 meter equals to 100 centimeter, no? So here again millimeter into 10 power 3 I should take. So when I take the zeros at the trailing, it is not a significance. Okay. So all have only 3 significant figure 264. All trailing zeros are not significance. Okay. So now we have completed significance. Now rounding off. Okay. So rounding off has 2 rules. Rule number 1 is if the number lying immediately to the right of the cutoff digit is less than 5, then the cutoff digit remains unchanged. Suppose 6.24 is there. I need to take only 2 significant. How many significants are there? 3. They are asking me to write in 2 significant. How should I write is, I need to eliminate this number. Okay. So there is a rule. First rule is number is less than 5. Okay. Second rule is number is greater than 5. Okay. Greater than 5. Third rule is equal to 5. Okay. Equal to 5. First rule what we are seeing is if the number is less than 5. If the number is less than 5, 6.24, how much is the less than 5 only, no? Yes. 4 is less than 5. So leave as it is. So you can write 6.2 as it is. Okay. If the number is greater than 5, what is the number? 7. Greater than 5, no?
6.3.
Add plus 1 to the previous number, which is 6.3. Okay, no? So this is 2 rules. So one more rule is, if a number is dropped is exactly 5 followed by the zeros, then if the cutoff digit is even, it remains unchanged. Cutoff digit is odd, increase by 1. 6.35, 6.45. Last digit is 5. See the previous number, whether it is odd or even. If it is odd, change to even. If it is even, leave as it is. It is odd, no? 6.4. It is even, no? 6.4. This is my rounding of rules. First rule, less than 5, leave as it is. Second rule, greater than 5, add 1 to the previous number. Third rule, equal to 5, see the previous number, whether it is a odd or even. If it is odd, increase by 1. I need to change to even. If it is even, keep as it is. Okay? Algebraic operation with significant figures. So what is the meaning of algebraic? Addition, subtraction, multiplication and division. So first we will see addition and subtraction. So when adding or subtracting measured value, then the least number of digits after the decimal among the number determines the decimal place in the result. We will see with examples. Okay, and keep in mind, addition, subtraction have one rule, multiplication and division have one rule. Okay, so addition and subtraction, I need to find, I need to see the least decimal value. Okay, I'll keep addition and subtraction, least decimal, multiplication and division, least significant. Keep in mind this one, we will do the problems. Now significant figures are there, like 4 significant figures they have given, 4 numbers they have given. They are asking me to add every number and find the final result of the numbers. Here the question is 1.2 plus 3.45 plus 6.789. 1.2 plus 3.45 plus 6.789. If I add this, I will get 11.439. Right now, this number is having 2 significant 1 decimal, 3 significant 2 decimal, having 4 significant 3 decimal. What is the rule of addition and subtraction? Least decimal point. So which is having least decimal point? 1.2. So take this to least decimal. Don't see the significant. Whether it can be how many significants also, no issues. Okay, I need to take to only 1 decimal point. So 11.4, but see the next number also, whether it is greater than 5 or equal to 5 or less than 5. If it is less than 5, leave as it is. Suppose I am getting 11.489. It is greater than 5, no? So what I should do? Add 1. So 11.5 is the answer. Right, no? Whenever I am rounding off to the significant figures, next number I should watch out. Right, no? Whether it is less than or greater than or equal to 5. Okay. So example 2, 12.63 minus 10.2. I am getting 2.43. So if I see here 2 decimal, 1 decimal. So how many decimal I need to take? Least decimal how many? 1. So I need to take 2.4, but what is the next number? 3. No need to do anything, so write 2.4 as it is. Okay.
In that case, will they not check number 9?
Which one? No. When they are asking for 4 significant, in that case I should check 9. Only 3 significance means the next number, 4th number I should check. Okay. Multiplication and division. What I said? Least significant. Okay, least significant. Suppose if I take 10 into 9, how many significance? 1. Here 1. So what is the answer? 90. How many significant I should take? 1 significant. So 9 is the answer, no? Suppose 102 into 4. How many significance here? 3. How many significance here? 1. So if I multiply, how much, what is the answer?
408.
408. 408. So I need to round it off to how least significant. How many what is the least significance here? 1. So I need to round it off. 400. 400 na? 400 is correct, no? So or I can write 4 into 10 power 2 also. How many significant? 1 significant, 1 significant. Right now least significant I need to take. So example 1.2 into 36.72, I am getting around 44.064. So here 2 significant, here 4 significant, round it off to 2 significant. The third number is 0, so no need to do anything. So 44 is the answer. Understood? Yeah, there are questions. Give answer for these questions now. So this is addition and this is multiplication. Give answer for these questions. First, give answer. So what is the answer for the first one?
260.5.
Final answer is 260.5. Is it? We'll calculate it. So what is the given question? 13.214 plus 234.6 plus 7.0350 plus 6.38. So answer is 261.229. No, 261.229. 261.229. So how many significance for the first one? 5. So I need to check the decimal values, na? Least decimal, no? 3 decimal, 1 decimal, 4 decimal, 2 decimal. What is the least decimal here? 1. So how many decimal I should take? 1. So 261 point, first decimal I need to consider, second decimal is 2. So no need to worry about anything. I can write directly 261.2 as the answer. What about the next question?
1909.5.
1909.5. Is that correct? 1909.5. So least decimal 5. I will keep as it is. Right now, least decimal I should take. That's it, na? I will keep as it is. So what is the answer for these cases? Tough one. Do, sir. 16 5s are 80. Do. Significant, least significant, na? 5 significant, 3 significant, 1 significant. The next number, what will come? 10 power something should come, no? So 16.235 into 0.127 into 5, 10.3. 10.309225. 10.309225. Okay, so what is the number I should take now?
1 into 10 to the power
336.
1, 2, 3, 4, 5, 6.
10 power 7, na?
Minus 7.
Minus 7.
No, sir. Minus 7.
Minus 7. So this is
Point
6, no? And one more 0 is upside, no? How? What will come?
1 into 10 to the power minus 7.
Is it correct?
Correct.
minus 7 in the sense 1 point will come, no? Here 3, 6, here 0, minus 5, na? Yes, no? Minus 5 should come, no? 10 is upside and remaining 6 zeros are downside. Minus only should come, minus 5 only should come, no?
10 by
Yes. So what about this one?
So you can do simple calculations.
0.00435 into 4.6. We are getting 0.02001. 0.02001 is the value. So what is the least significant here? 2.
2
2. Okay. What I should take now? What is the answer should come?
2.0 into 10 to the power 10 to the power minus 4.
0.020. That's the answer.
We can also write 2.0 into 10 to the power minus 4.
Minus 4 in the sense the zeros will come before.
Minus 4 down 0.
How?
These
2 point?
become
2 point?
0
2.0.
into 10 to the power minus 4.
Fine. We'll go for the next one. Permissible error. Okay. So permissible error is the maximum allowable error. Okay. So suppose if I am measuring something, they will say that only this much should be the error you should maintain. If it is exceed, I can't use that. Okay. So if I take a bottle, if I take a cap, okay, some measurement will be there for cap to fix in that bottle, na? So they will say that this is the measurement. It can be plus or minus 0.1 centimeter also or 0.1 millimeter also. Okay. So there will be some particular error which is allowed. That error is called a permissible error. So which is acceptable for the particular instrument or measuring device being used. It is also called as least count error. Okay, permissible error also we can say, or a least count error also we can say. The smallest error that can occur due to the limitations of the instrument precision. Okay, example, if you measure a length L equals to 26 millimeter, then the maximum value of a true value may be 26 plus 1 or 26 minus 1. It can be exceed 1 or it can be decreased by 1. Okay, any doubt in the permissible error? So which is maximum error allowed?
Which is plus 1 or minus 1.
Okay, right now. So we'll continue with the next topic in the next class.